Hi, and welcome to this short overview of the second session in our unit on how computers do stuff. This session focuses further on exploring successful approaches in helping pupils manage the transition from block-based to text-based coding. Although I can only give you a brief taste of what the full session covers, I hope to show how the proven practical approaches to teaching and learning it explores can be of help to you and in turn your pupils. The central aim of all these sessions is to simply and directly enable teachers to further enrich and broaden their own teaching toolkit through clear subject knowledge tied directly to practical investigations and computer science pedagogy in Key Stage 3 and above. At the same time, building a buffet of practical resources and approaches to teaching that can be drawn upon, adapted and used directly to enrich pupils' experience of computer science. So, let's see how this session can be of benefit in the teaching of proper programming. As the full session unpacks, although here we are looking at small basic, our focus is not on teaching one specific language, but rather exploring a broader approach which covers those important foundational aspects that can apply across languages, where the act of problem solving through programming is always central. You see, computing is about much more than programming. Computing is about developing a way of thinking. Because of this session and others bring to the fore those central skills and aptitudes of computational thinking through programming in order to bring those central thinking skills to life in ways that are transferable across programming languages and environments, with the specific aim of helping children to walk before they run. As I have said, in this particular session we do this through Small Basic, designed by Microsoft. This is a particularly useful environment, as it is designed with tools that can help manage the cognitive load faced by pupils when making the step to text-based programming. Though as mentioned, the approaches and techniques explored are fully applicable to any language you might choose to use in your classroom and can be adapted in many ways. Basically, the pedagogy, approaches and aspects of programming covered in the session will be of use wherever pupils code. All these sessions have the primary aim of providing practical and specific outcomes that can be used directly in the classroom. And, after undertaking the sessions as a whole, you will go away with a number of specific practical outcomes that you will be able to use in ways that suit your own classroom environment. In this particular session, these outcomes are to recognise the key concepts and constructs for tackling programming challenges, be aware of the barriers students face when learning to code, appreciate some of the tools to assist in the transition to text-based coding, become familiar with the Small Basic IDE and develop the language of objects, along with having the opportunity to explore a range of activities for introducing programming concepts in Key Stage 3 and upwards, while at the same time exploring through practical activities just how computational thinking underpins this learning in order to bring computational thinking to life in the classroom. At the heart of the session is the exploration of Small Basic and how an approach to reading code first is an essential step towards writing code effectively. A key pedagogical approach that can help pupils manage their transition to text and enable them to handle such issues as a syntax barrier that can so often be a hurdle to their progress. The session does this through a series of activities where we show just how pupils can be asked to read code and provide specific predictions about what will happen when the code is run, as well as how to develop clear reasons as to their predictions. Going on from there to develop approaches for them to be precise in how they describe elements of code and understand how to make predictions supported logically by what they have read. Then, how to take these predictions and apply them to the code when it is run to see if it behaves how they predicted and, most importantly, why, or why not. Through these predictive activities, the session looks at how we can then return to the initial code to explore how those predictions matched the execution or did not, before returning to look at the code again with all this in mind. In these exercises, which include a number of algorithms and constructs working up to both counter-controlled and condition-controlled loops as implemented in Small Basic, it looks at how misconceptions can occur and how to unpick these misconceptions through the reading and prediction of text-based code. As well as looking at different algorithms in this way, the session unpicks how we can use this approach to introduce new concepts and classes, such as the relationship between properties and methods and how these are implemented in Small Basic. Using references to previously understood concepts while we do this to help them build a strong mental toolkit which they can then use when they code, in order that when they come to write using them they have a deeper conceptual understanding of what they are writing. In fact, as the session makes clear, This approach of reading and predicting text-based code should be a prerequisite for children learning to code, and should be built into the process to ensure a better understanding and to help them manage the cognitive load that this transition to text can entail. At the same time, this step to read before writing doesn't mean just endlessly reading code. Rather, the session shows how it acts as an important foundational aspect of coding that allows pupils to examine and experience code in ways that brings thinking and problem solving to the fore. And, with each example explored in the session, pupils can then go on to use the examples to write this code in novel ways themselves, but with greater understanding. As such, it looks at those tools available in the Small Basic IDE designed to assist learners, and especially how its IntelliSense panel can be of real help in enabling pupils to manage the syntax barrier more effectively. In particular, just how the environment's IntelliSense contextual help function enables commands to be selected rather than having to be written, and can be of real use to pupils in helping them to manage the cognitive load that comes with learning a new language. As it looks at how to program in Small Basic, the session also examines how programs are combinations of algorithms and data structures, going further to explore different kinds of data that can be stored in data structures such as a variable, and that depending on the data type, different things can be accomplished with them, along with the different ways we can introduce these data types to pupils, and how they can differentiate between them and their uses in Small Basic and other languages. Again, helping to make clear those approaches to teaching that gives pupils the tools they need to lower the levels of cognitive overload that might otherwise act as a barrier to writing code with understanding. Finally, using all that has been explored through the session, it goes on to look at one final practical exercise where pupils can take all that they have learnt and implement it in code from scratch, but armed with the tools, concepts and approaches they need to do this. In this exercise, they will be using Small Basic and all of the tools designed to help them to implement FizzBuzz, a classic test of the ability to structure constructs correctly, and something they should be ready to do now with all of the approaches that the session has laid out towards achieving this. And you as a teacher of computing will go away with those specific outcomes to help enable them to do this in ways that are more effective than many other approaches. These outcomes being to recognise the key concepts and constructs for tackling programming challenges, being aware of the barriers students face when learning to code, appreciate some of the tools to assist in the transition to text-based coding, and to have become familiar with the Small Basic IDE and develop the language of objects, along with having had the opportunity to explore a range of activities for introducing programming concepts in Key Stage 3 and upwards, while at the same time having had explored through practical activities just how computational thinking underpins all of this learning process in order to bring computational thinking to life in the classroom. I really hope you've enjoyed this overview, and though this video is designed only as a brief introduction to the session, I recommend that now you have watched it that you visit the Tenderfoot program online to find out more, to find out just how you can benefit from the session as a whole and how and where you can undertake it. You'll find the link to Tenderfoot Online in the description below, as you will links to CAS Online, where you can visit and join our grassroots community for even more support, resources and ideas dedicated to the teaching and learning of computing at school. For now though, I will leave you with this one thought to ponder on. Why would getting pupils to write first not be the best strategy?